All right, guys. So now we're going to talk about like why do we calculate standard deviation? What does it tell us? What is it? How does it like relate to our data? Why do we even care about standard deviation? Okay. So if we were in class, normally I would have you guys find the standard deviation of this set of numbers, but we're not in class and you guys already are doing your homework where you have to do this. So I went ahead and found it for you. So in this problem, I found that the mean is 7.3 and that the standard deviation is 3.3. So what we do with these problems is the standard deviation kind of tells us how spread out the data is, how far away the data is from the mean. Is it really close? Is it really far away? And things like that. So I'm going to create a dot plot for this list of numbers. The list is in the horizontal table. Um, we worked with dot plots a little bit yesterday when we were creating our box and whiskers. So I'm just going to put an X where every number is. If I have more than one of the same number, I'm going to stack the X's on top. You could also use actual dots, right? It's called a dot plot. But I used X's for the PowerPoint. So we'll let those fall for a little bit. And this is just giving me a nice visual representation of where the data is. It also, drawing a dot plot makes it very easy to find things like your mode because it would be like just the tallest stack. And we're going to be doing these things tomorrow called histograms. And histograms also gives us a nice visual representation of our data. So you can see that this one, I mean, it looks pretty evenly spread out to me. Okay, so next what we're going to do is we're going to plot our mean, and our mean should be somewhere towards the middle. It might not be in the exact middle, especially if our data is skewed. And we'll talk a little bit more about skewed data tomorrow, but it should be somewhere around the middle. So my mean that I calculated was 7.3, so that's going to be between the 7 and the 8, so right here. Then what we do is we start at the mean, and we go out one standard deviation in each direction. So we'll be going to the right and to the left, one standard deviation. Each direction is one standard deviation, so 3.3 spaces away. What I'll do on my calculator is I will do 7.3 plus 3.3. That gets me to 10.6, which is like halfway between, or somewhere between, right? The 10 and the 11. And then I'll also go backwards, 3.3, right? So 7.3 minus 3.3, because we're going to the left. And that gave me 4. So that's going to be like right on the number 4, right? So I'm going to draw my other blue line right on the number 4. All right. So we have between 4 and 10.6. That is called one standard deviation away from my mean. Okay, one to the right, one to the left, right? It's one standard deviation away from the mean. And some questions that I can ask you is I can ask you like, how many numbers fall within one standard deviation? So then you would count the amount of X's that are between 4 and 10.6, right? So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 of my numbers fall within one standard deviation. That's a lot. There is like a percentage of numbers that are supposed to fall within one standard deviation. It's definitely over half. It changes with every problem, obviously. But so that's something we can ask you though, is like how many numbers fall within one standard deviation? In this particular problem, if you read the question at the top, it says, within how many standard deviations do all the numbers fall? So what we want to do is we want to keep going out until we have encircled all of the X's. So I'm going to go, I'm at one standard deviation. I'm going to go one more in each direction. So from my 10.6, I'm going to add another 3.3, which gets me to 13.9. So close, guys. Oh my gosh, we were almost there. And then from my 4, I'm going to minus 3.3 because we're going the other direction, right? And that gets me to 0.7. So now within 2 standard deviations, I almost have all of my X's. I'm just missing that 14. Sometimes all of the numbers will fall within 2 standard deviations. It's a lot more common though within 3, and it's very, very rare that it takes more than 3. It's definitely going to all fall within 3 because I mean I was right there. I was 0.1 off. So if I went out that 3rd standard deviation, I would collect that last X. So this is how standard deviations work. And again, by knowing the standard deviation, it kind of tells you like how spread out or how close the data is that you collected. So if we look at these two problems, this is the one, the top one is the one we were just doing with a mean of 7.3 and a standard deviation of 3.3. And then this is actually the example from the first video where the mean was 70 and my standard deviation was 11.8. So if we look on both of my number lines, I was counting by twos, but look at how much bigger the bottom number line had to be. And look at how much bigger the standard deviation is, right? I had to go 11 spaces away from the mean to get to my first standard deviation. And that collected 4 out of my 6 data points. In my first one, I only had to go 3 spaces away and I collected, well over half of my data points, right? I was only missing 4 of them. So again, standard deviation tells you how spread out the data is, and we can ask you questions about like how many numbers fall within a certain standard deviation, and things like that. So that's why we need to know about standard deviation, and we're going to actually talk a little bit more about standard deviation tomorrow, but that's it for today.